Hello and welcome back. The following problem says how many hydrogen atoms are in 3.4 grams of C12H22O11. When approaching this problem, we need to first identify what we're looking for. We're looking for hydrogen atoms. And they give us grams of sample. Well, in order to go from grams to atoms, what is our first step that we have to do? Well, in order to go from grams to atoms, we first need to convert to moles. So we're going to go from grams to moles of sample, so of C12H22O11. But do we want moles of our sample? No, we want to then convert to moles of hydrogen because we ideally want hydrogen atoms. It is important when you read these questions, you're identifying exactly what you need. So then we need to convert to moles of hydrogen, and then finally to hydrogen atoms. And so in order to do these, we know in order to go from grams of sample to moles of sample, we can use our molecular weight, and our molecular weight has units of grams per mole. So that's going to be our first conversion factor. And then to go from moles of sample to moles of hydrogen in that sample, we know for every 1 mole of sample, we have 22 moles of hydrogen. So we can use this as our conversion factor. And then finally, we can use Avogadros number to go from moles to atoms. So let's go ahead and set this up. We're going to first put down 3.4 grams of our sample, which is C12H22O11. Well, we need to convert using molecular weight. And in order to determine molecular weight, remember you just add up the molecular weights of each of your atoms. So 12 times the molecular weight of carbon, which is 12.011, plus 22 times the molecular weight, which is 1.001, plus 11 times 15.999. And once you do that, you end up getting a molecular weight of 342.297. And this is grams of C12H22O11. And that's 1 mole of C12H22O11. Well, good. Our grams and grams cancel out. Now we have moles. Well, in order to cancel out moles, we need to now convert from moles of sample to moles of hydrogen. And we said for every 1 mole of sample that we have, C12H22O11, we had 22 moles of hydrogen. Because that's ideally what we want for the end problem. We want hydrogen atoms. So we cancel out moles and moles. The next thing that we have to do is multiply by Avogadros number, which is the chemist does, and that says 1 mole is equal to 6.022 times 10 to the 23rd atoms. So we want atoms on the top, so 6.022 times 10 to the 23rd atoms of hydrogen atoms over 1 mole of hydrogen. So moles of hydrogen and moles of hydrogen cancel out, and we are left with our final answer being 1.3 times 10 to the 23rd hydrogen atoms. So remember, when you're approaching these problems, you're identifying what you're looking for. You can draw a think map of how to get there, and then you can start using your units to help guide you throughout the problem. Thank you.